Okay, so capital budgeting is actually also called investment appraisal technique. And we're talking about investment projects are appraised using a combination of a number of techniques. No one method is used in isolation to ensure that a correct decision is made for a given project. So the following are some of the methods used to appraise projects. The first one is the net present value, okay, and then the payback period, discounted and non-discounted, an internal rate of return, accounting rate of return, as well as the profitability index. So these are the 5 techniques that are used in capital budgeting. All right. So these methods can be further classified between discounted cash flow methods, meaning the cash flows are discounted at a given rate, and non-discounted cash flow methods, where cash flows are not discounted. So net present value, we start with the net present value. So net present value is just a sum of present values of all cash inflows minus the initial investment in the project. Okay? The sum of present values of all cash flows minus the initial investment in the project for NPV. All right. So the NPV method compares the present value of future cash flows from a given project with the initial cost of the project. The future cash flows are discounted first at firm's cost of capital or required rate of return, so that they are compared at their present value, taking into consideration the time factor. So the rejection acceptance rule, the rule is that we accept projects with positive NPV and reject those with negative NPVs. So advantage of NPV takes into account the time value of money, uses cash flows not accounting profit, takes account of all relevant cash flows over the life of the project, and of course, gives absolute measure of the project value. Then we get into the disadvantages. So the cost of capital may be difficult to find, and then cost of capital may change over the project life. Okay. And of course, the project cash flows may be difficult to estimate. All right. So let us look at this example here. You can read this question for us. What is important for us to understand the concept? This question 1 says what? Can you read for us the question says what? What's the question? Madam Melissa?
Question 1.
Yes.
A firm expects the following stream of cash flows from its project of $500,000 per annum for 5 years. The project's initial costs are $1 million and the company's cost of capital is 10%. Determine whether the company should take this project or not using NPV.
Okay. All right. So you have made an investment in the project. So how much? The initial cost of the project was 1 million. And then you start getting back a 500,000 per annum for 5 years. So you are making an investment at year 0. Okay, so DCF means discount factor. When you come across the DCF, okay, so DCF means what? Discount cash flow factor.
Discount cash flow.
It is a discount factor. All right, so how you get the discount factor? You would say just 1 plus r to the power negative n. This one is also called present value interest factor. So it's called present value factor. Okay, so this is what goes on. So as we get to this question here, the all right, so we move on. So for those who are asking, this is corporate finance, please. For financial managerial finance or corporate finance. So you must start multiplying now. So here you multiply these two to get the last one. Then here you multiply to get the last one. You also multiply here to get the last one. You multiply, get the last one. You multiply, get the last one. You multiply, get the last one. So say sum of present values of all cash flows minus initial investment in the project. So add all these now. After adding all these, minus the initial investment in the project. So accept the project if NPV is greater than 0. Otherwise, reject the project. So if NPV is greater than 0, so NPV greater than 0, accept the project. Otherwise, reject it. Okay. I'm sure we are together so far. So you've seen where the fourth with the fourth.
Sorry, could you explain why we are rejecting the NPV?
I'm saying I'm not saying that we are rejecting. I'm saying that the criteria here is that you accept the rule is that we accept projects with a positive NPV, and then you reject the project with negative NPV.
Okay, no problem. I just had we reject. Okay, I get it now.
So now you know why we are doing here. These cash flows of 500,000 was a year for 5 years, not so. 500,000, 500,000, 500,000, 500,000, 500,000. Okay, so this is what we have. You know where the discount factors were coming from? This one, the 0.90. We are using the 10%. So for year one, our discount factor, we will simply say, so year one is equal to 1.1, the power negative 1. You give me the fact. Year two, you see 1.1, the power negative 2. Okay, so 1.1, the power negative 2. Then year three, it will give us 1.1, the power negative 3. Start getting the factors. Year four, 1.1, the power negative 4. This is how you're getting the factor. So year five, is also 1.1 to the power -5. Okay. So this is how we are getting these factors. This is how the factors were obtained here. It's okay? Is that okay?
Very clear.
Now,
Are we also going to be given a discounting thing? Does this one have a table?
They will give you the table, yes. If they will give you the financial tables at the end of the question paper. So let's see where you get these ones. The 0.9, 0.9091, 0.8264, 0.7513, 0.6830, 2.26209. You've seen these ones, right?
Yes. Another question is, we are always going to be given the expected cash flow?
Yes, those ones are given. And the cost of capital they'll give you in a question like yes, the 10% they'll give you. If it's a 10% or whatever rate you want, they'll give you.
okay, now, sir, what's the difference between those factors have been given and multiplying the cash flows by 1.1 or dividing, sorry?
What are you saying?
I was thinking that, or what I don't know. I was thinking that because the discount factor there is 10%. So we say 1.1 divided by the 500, it would give us the present value. Is that different?
What are you saying? 1.1?
1.1?
Uh-huh.
500,000 divided by 1.1.
No.
To discount.
Just find the discount factor independent way. Just find these factors, then you multiply them.
So if they have not given us these factors, they've just told you to say these cash flows yearly, and then the discount factor per year is 10%. How do we handle that one?
If they have given us what?
They have given us the 10% as the discount factor per year, but they have not given us cost values. How do we handle that one? The discounted factors, those now which have been calculated at 10%. The 0.9, 0.8, 0.7. If they haven't given you those, they have just given you the discount factor to be 10%. How do you handle that one?
You solve manually using this way. You've seen all the workings that I'm doing it. This is how you get the discount factor. Year one, you use this 1.1 to the power -1. To give us the 0.9091. Okay? You have a calculator with you?
Yes, I am.
So if I will give us the 0. This is how these ones are found. H264.
Just don't know how to aviate the negative there. How do? Yeah.
Use a calculator. I don't know which calculator you are using, boss.
Okay, maybe.
0.8.
On your calculator, there's a thing like a V there. So when you do that V, it means you're powering. So you can power to any amount. Then you can start with a negative, then the number that you want to do the power. So just write 1.1, press on the V. The V is looking down.
Yes.
Yeah. Yes. Then now put -1, -2, just like that. They'll give you the.
Okay. So sir, when I tried to divide 500 by 1.1, it's giving me almost the same, but I need to round off me to reach that value.
There's no
the one which is. Okay. All right. Thank you. Thank you, sir.
So, but this is how you're getting the factor.
Okay, now I've gotten the point.
So I thought for factor 1, factor 2, factor 3, factor 4, and factor 5.
Okay.
Okay, is that okay?
Yes, it's okay, sir.
So this is what is going on. All right, so you need to multiply now. So this one. To multiply this one, you get the last one. To multiply, you get this other one. Then you multiply here, you get this other one. You multiply, you get this one. So you see now you're getting these values now.
Yes, sir.
This one, so add this one, add this one manually. If you have calculated, add this one manually. Minus how much you invested in the project, minus how much you invested in. How much are you getting? You're getting 895,350. It's a positive NPV. So accept project because NPV is greater than 0. Accept project. Because okay, NPV is greater than 0. All right, is that clear?
Yes, sir.
What about the rest?
It's clear.
Clear on my part.
All right, so that is NPV. So the project with a positive NPV, hence the company should accept this project. All right, so this is what we have. But this was an annuity. If you've done time value of money. So if you wanted to use a shortcut, you find the present value interest factor for annuity. Okay, so this is the same amount as an annuity. Okay, so meaning you do sum of annuity. So present value interest factor annuity is equal to amount, then 1 minus 1 plus r to the power negative n over r. Okay, so after this, once you get this, then you subtract the what? How much we invested in the project. So you put the 500,000 here. So 500,000. Okay. Then 1 minus 1.1 to the power negative 5 over 0.1. What answer are we getting? Give me the answer to this one. This is an annuity. So find the present value of an annuity. What answer are we getting?
I have 1,895.39.
1,895.
No. Actually, I think I have a larger value. It's actually 1,895,393.
Okay, so 1,895,393.
393.39.
393.39. Okay. So this is the total present value. So total present value of cash flow. So our NPV will be equal to the same amount, 1,895,393 0.39, then minus a 1 million. That we invested, you remember what the 1 million?
Yes, sir.
Yes.
Our NPV, so this is the shortcut, because it was an annuity, it was the same amount. So it is giving us what? 895. Okay. 393.39. Okay, are we together?
Yes, sir.
Yes,
Yeah.
we are.
So this one is a positive NPV. All right, so it's okay. You can invest in the project. Now let's go to the second criteria for NPV. So this is the NPV. So we can go to the payback period now. All right. So payback period. So under payback period, we are simply saying payback period, this can be discounted or non-discounted. So the payback method measures the length of time the project takes to pay back the initial cost of the project. So how long it takes for you to recover the exact amount invested in the project. The period is counted as 1 full year, where the entire cash flow is used to pay back towards the capital, or in the year a portion is required to complete the full payment. Fractions multiplied by 2. So accept projects with a shorter payback period. Projects with shorter payback period are accepted over those with a longer payback period. Advantage of payback, it's simple concept to understand, easy to calculate, uses cash flow not accounting profit, takes risk into account. All right, first is on the advantages. Okay, so you are able to follow, not so. So advantage of payback, the method, simple concept to understand, is to calculate, uses cash flow not accounting profit. Advantages, it ignores cash flows after payback period and does not account for time value of money. It ignores the time value of money, all right? And it ignores other cash flows after payback period. It ignores other cash flows after payback period. Okay. So we can look at an example here. We have this question 2. Question 2, at year 0, we invested how much? 0, we invested both projects A and B. We invested how much?
$1,000.
Yes, but what have we recovered in year 1 for A project
Year
A?
1 in project A, $400.
So let's look at project A. So our payback will be how many? We have got 2 years first. 2 plus, for 2 years we have recovered how much? 800. So 2, now you say 1,000, the 1,000. Okay, so it's 1,000 minus 800. So it will be 1,000 minus what? 800. You know why I'm doing this? We need to recover the exact amount that we invested in the project. So in the project, we invested how much? 1,000.
1,000.
So we need to recover that exact amount, the 1,000. So how long will that take? So far we have recovered the 800. So the remainder, you can recover it from this other 400. So the remainder is a 200, which you can recover from the 400. So you see my fraction here. So we have said invest 2 years for now. 2 years for now. Okay, so it will be 2 plus 200 here, divided by 400. So what are we getting now as payback? So simplify this one first side. And so what's the payback now? It will be 2.5 years. So the payback will give us what? 2.5 years. Okay. Are we together?
Yes, sir.
Yes, we are.
Yeah, so this 200, we recover it from the 400. So it's 2.5 years. So this is how they found the 2.5 years payback for project A. Then that of project B, it is exactly 2 years without the remainder. So project B has a shorter payback. Okay. Is that clear?
Yeah.
So project B, it is exactly 2 years, the payback period. Okay, exactly 2 years. All right, so this is how the issue of payback is sorted out. I'm sure it is clear from the techniques that we use in capital budgeting. So we have done the NPV and payback. Let's move on to the other one. So the other one we can look at is the internal rate of return, number 3. So internal rate of return, this method uses discounted cash flows. Internal rate of return is the rate of return that gives the NPV, which is equal to 0. This means to get an NPV of 0, the initial cost should exactly equal to the present value of future cash flows. In other words, the project breaks even. The internal rate of return represents the minimum rate of return that the project would yield. Okay. So now, then, this is how you calculate the internal rate of return is calculated. Okay, so our internal rate of return, okay, is equal to L1 plus NPV1 over NPV1 minus NPV2 then B2 minus A1. So accept the project is N internal rate of return. So A1 is rate 1. Rate 1. B2 is rate 2. So rate 2, so NPV2 should be negative. NPV2 should always be negative. Okay. Okay, so always be negative. So set rate 2 as high as possible to give NPV to negative. Set rate 2, which is B2, very high. very high. In order to get NPV to negative. So this is what goes on here. All right. So you can see that internal rate of return somewhat complicated. It depends on two NPVs for it to be completed or for it to be computed. Okay. So you have seen this one. So we're obtaining internal rate of return formula. Internal rate of return A1 is rate 1, NPV1, NPV1 minus NPV2, B2 minus A1. So A1 is the lower rate. This one is a higher rate. NPV1 should be positive NPV, negative NPV. Now, using this method, we need to find two NPVs, one NPV positive and the other one negative. Then proceed to use the formula. All right. Negative NPV is bound by increasing the discount rate. Okay, that is what goes on. Accept or rejection rule. A firm should accept all projects that have NPV greater than the cost of capital and reject those that have internal rate which is less than the cost of capital. Advantages of internal rate of return is closely related to NPV. Okay. Okay, so it is closely related to NPV and easy to understand when information is given and communicate. The disadvantages of internal rate of return. Okay, so we are simply saying a problem is applying internal rate of return to projects in non-conversion of cash, and then it also depends on NPVs for it to be computed, and it uses two rates. So these rates they are obtained on trial and error. So the first rate, they will just give you one rate. So trial and error. So they'll just give you one rate in an exam. Okay, so the other rate you just set it for yourself. So you check from the financial tables, you use a rate that is high as possible, the largest possible rate. Okay, that's what goes on. So question 3, we can now how much have you invested? Let's look at this question 3. How much have you invest? You can see at year 0, 1,500 not so. Are we together?
Yes, we are.
Invested 1,500. Now from year 1 to year 5, you are receiving 500,000. So it's an annuity. So this is an annuity factor. And now they got it. You just said 1 minus 1.1 to the power negative 5, then over 0.1. So if you have calculated, you will discover that this is how they found it. We found this amount here. So they are given the first percentage was 10%. So that's the only percentage they give you. But in an exam, you use it, you have to get a negative NPV too. Okay, so the first NPV should be positive. So first NPV should be positive. Then the second NPV needs to be negative. So here, are you getting the 3.7908? Are you getting this one?
Yes.
Okay, so after you get that one, then subtract the 1.5. After you multiply, you get 1,895,400 minus 1.5. You're getting the positive NPV of 395,400, right? 395,400. Okay. We're subtracting 1,895,400 minus 1.5, 1,500,000. You're getting 395,000, 395,400. 395 what? 400. Okay, is that okay? So this is NPV1. So this is on the aspect of NPV1. In NPV2, you can select a rate as high as possible. You can say 10% rate 1. The other one you can put at the 30%, 30 or 32%. Here they are used 32%. But you can start from, if 25% will also give you a negative, you can also pick it. So there is no restriction on the rate to use, but use the largest possible rate that will result into the negative NPV2. Is that okay?
That's not.
Aaron? Have you gotten it? So these were annuities. So a 500,000 was an annuity. So to get an annuity factor, you had said 1 minus, the other one is 32 divided by 100. Okay. So 1.32, okay, to the power -5 over 0.32. So this is how they got this factor, 2.3452. So 2.352, multiply these to get this one. Then subtract this one minus that one to give us a negative 327,400. So in your own time, you can still use a rate of 30% maybe. Even 30%, you can use 30%, it will still give you a negative, well and good. Okay? So if the 30% will still give you a negative, you can still use it. So after now getting so this is the present value annuity. Present value interest factor of annuity. We have this one. So now substituting the figures where we have. Okay, so we have the positive NPV1 using the formula. The formula we are still using is this one here. A1 was 10%. So 10%, 395,400, bring it down. Now this is minus, it gives us a positive here underneath. Okay, so this one is 395,400 minus 327,400. So you can see that this is giving us a plus. That's why they added here. So you're getting the internal rate of return of 22.03, which is greater than 10%. So accept the project if the internal rate of return, okay, is greater than cost of capital. Okay, I'm sure you have gotten to my point. Is it clear?
Maybe just to clarify. So you said that for IRR, you accept the project if you accept the project if IRR is greater than the company's cost of capital, of which in this case the company's cost of capital was is the cost of capital the 10% or the actual initial investment?
The cost of
What
capital.
is the company?
The company cost of capital is a percentage, which is 10%. This one.
Which is 10%. Okay. All right. So the interest. Okay.
This one. Is that clear?
Yes, that's
So we
clear.
use
Thank you.
the discounted interest, not the figure, the 1.5. So, okay.
What I saying?
It's fine, I've seen. Because yeah, it makes more sense now that the RR is in percentage. So yeah, I now understand why we're using the percent, the discounted factor, and not the amount itself per se.
Okay. All right. So we now go into profitability index, another technique. So this is simply the sum of present value of all cash flows divided by initial investment. It's almost similar to NPV. So PI is equal to sum of present values, and you divide by initial investment. So accept project if PI is greater than 1. Otherwise, reject the project. So the sum of present values divided by initial investment in the project. So an example, the sum of present values, or if we have the cash flow, we have invested how much? We have invested year zero. Year zero, we have invested 1 million. Then year 1 to 5, we are getting, so this investment is in brackets, then you are getting 500,000. So let us find the present value here. If the rate is at 10%, so rate, if it is at 10%, what are we going to? It's an annuity, so it will be amount, then 1 minus 1 plus r to the power negative n over r. It will give us 500,000. Then 1 minus 1.1 to the power -5 over 0.1. How much are we getting now? So 500 we're getting
1,895,393.39.
or 0.385 or 0.339. So in this case, our PI will give us what? PI will be equal to, these are the total recoveries, not so?
Yes.
Total recoveries. Then you divide by the 1 million. So this expenditure, okay, this one that was in red here, it is how much we invested, but we have recovered 25 by 1 million. It's giving us 1.8 what? 1.895.
1.895.
So accept project if PI greater than 1. Accept project. Okay. So the 1.895 is greater than 1. So accept the project in this case. Okay, I'm sure it's clear so far. So if the recoveries are less than how much we invested, then don't invest that project. Understood?
Understood.
So advantages is closely related to NPVs may be useful when available investment funds are limited, easy to understand and communicate. Then its advantages, okay, may lead to incorrect decision or comparison on exclusive projects. And this one does not account for profit. Okay. Does not account for profit. So this is it. What goes on? All right. So now we look at the last one, which is the accounting rate of return. So accounting rate of return uses accounting profit and losses. So accounting rate of return uses accounting profit or losses, not cash flows. The difference between accounting profits and cash flows is the accounting profits include non-cash flow depreciation. So the depreciation is equal to initial cost minus salvage value divided by the project life. So how you get the depreciation? Initial cost minus the salvage value divided by the project life. So to convert cash flows into accounting profit, we subtract the depreciation. So to convert accounting profit to cash flows, we add back depreciation. So accounting rate of return. Okay, so accounting rate of return is equal to average accounting profits or losses divided by average investment. This is the formula for accounting rate of return. So accounting rate of return is equal to average accounting profit on losses divided by average investment. Okay. So average investment is equal to initial cost plus salvage value. Then divide by 2. Initial cost plus salvage value divided by 2. Then accounting profit is equal to sum of profits and losses divided by project life. So sum of profit and losses divided by the project life. That's an average what? Accounting profit. Okay. Sum of profits and losses divided by project life. Then the average investment is initial cost plus salvage divided by 2. So if the company acceptance criteria, if the company target rate is less than the computed accounting rate, we accept the project, otherwise we reject the project. Then advantages of accounting rate of return, easy to calculate, need information will usually be available. Then disadvantages does not reflect the true rate of return since it ignores the time factor, value of money. It is based on accounting numbers. So question 5, let's look at question 5. You can read the question for me. Why is it question 5? Madam Melissa.
A company has the following profits from a project over a 5-year period. That is 2,000, 1,500, 2,200, 1,200, and $4,000. The initial investment is $20,000. The company's target accounting rate is 19%. Find the ARR.
Okay. So here you need to find the average profit by simply adding all these ones. This one, this one, this one, this one. Average profit, which gave us 2180, right? 2180. You've seen it? Have you seen it?
Yes.
Which is 22,008, which is this one. Then the average investment was initial cost plus salvage value. Initial cost plus salvage value. So initial cost is 20,000 plus salvage value was not given, which is 0 divided by 2, which is 10,000. So average rate of return is 21.8%. And their target accounting rate was 19%. So here, criteria for acceptance is that if the target rate is less than the computed accounting rate, we accept the project. So here, our target rate is 19, and we have computed what? 21 point what? We have computed the 21.8. So this is on the better side. So you accept the project this way. Okay, so the project is acceptable since the accounting rate of return is above the company target of 19%. So this is how these investment approach techniques apply. All right. I'm sure you have understood. Is that okay?
Yes, understood.
Okay, thank you very much. And then we can go to okay, so